So the next thing we're going to look at with exponents involves some different things with division, and we'll also get to some different things today with what happens when an exponent's negative. So similar to what I showed you with some different things involving exponents with multiplication, I'm going to kind of show you first sort of a way to sort of work these different problems out, and then we'll talk about some different things with shortcuts. So one of the things to keep in mind with division is that anytime you have a variable that's the same on the top and bottom of the fraction, they can cancel each other out. So if I have here x to the fifth over x cubed, just remember that x to the fifth is x times itself 5 times, and then x cubed is x times itself 3 times. So you have something like that there. So then from here, I can cancel out anything that's the same on the top and bottom. So I'm canceling out 3 pairs of x's, and then what I'm left with is the answer. So just notice that I'm left with 2 x's on top, so that would be x squared. And then there's nothing left on the bottom. So just remember, we talked about how whenever you have a variable with no number in front of it, it's a 1, and whenever you have a variable with no exponent there, that's also a 1. Well, whenever you're doing division and everything cancels out on one side of the fraction or the other, you always put a 1 in place there. So if you take this here, if you do x squared divided by 1, just remember that anything divided by 1 is itself. So you have x squared over 1 would be x squared. Don't ever leave a fraction with a 1 on the bottom. That needs to be simplified. So anything divided by 1 is always just itself. So that's the first example there. So just note as far as shortcuts go, whenever you have variables that are the same when you're dividing, the shortcut is simply to just do bigger exponent minus smaller exponent, and then your answer goes on the side of the fraction that has the bigger exponent. So if I do here bigger minus smaller, 5 minus 3 is 2, so the answer to this is x squared, and the answer goes on the top of the fraction because the exponent on the top of the fraction is greater than the exponent on the bottom of the fraction. So same thing with the second part. If you take, once again, just talking about how you'd work this out, so this would be on the top, x cubed would be x times itself 3 times, x to the fifth would be x times itself 5 times. So once again, I can cancel anything that's the same on the top and the bottom. So what I'm left with is, on the bottom, I'm left with x squared. On the top, I'm left with nothing, so I'm going to put a 1 there. And that fraction just stays like that. 1 on the top of the fraction is okay to leave like that. 1 on the bottom of the fraction is not. You want to divide that out. So same thing here if we're talking shortcuts. If I do bigger minus smaller, 5 minus 3 is 2, so the answer to this is x squared, and the answer goes on the bottom because there's more x's on the bottom than there is on the top. So that's just some different things with the shortcut there. So let's apply that shortcut to some other examples. So just note with this example, you have coefficients. You have numbers in front of the x's here. So whenever you have coefficients, always reduce them first. So 2, 6, remember 2 goes into both of those, I can reduce that to 1/3. So just remember, if reducing fractions is something that you have a hard time with, use your calculator to do that. You can do the alpha y equals and then put in 2 over 6, and the calculator will reduce that for you. Then if you take a look at the variables, I got x's here, x to the fourth over x to the fifth. So if I do bigger minus smaller, 5 minus 4 is 1. So the answer to this is x to the first. And the answer for this goes on the bottom because there's more x's on the bottom than there is on the top. And that would be the answer for that one there. So next I have this, and just note that there's 2 different variables here. There's nothing to reduce because there's no numbers in front of the variables. So I'm just going to kind of go one at a time here. So I have x cubed over x to the fourth. So 4 minus 3 is 1. So the answer to this is x, or x to the first. And the answer goes on the bottom because there's more x's on the bottom than there is on the top. And then I have the y, so remember this is y to the first. So when I do bigger minus smaller here, 2 minus 1 is 1, so the answer to this is y, or y to the first, and the answer goes on the top because there's more y's on the top than there is on the bottom. So just make sure you're always doing bigger minus smaller, and just make sure that you're always putting your answer on the side of the fraction with the larger exponent. So this one here kind of takes some reducing in with some different things with subtracting the exponent. So once again, you have coefficients here, so you want to make sure you reduce those before you do anything else. So negative 10 over 6, 2 can go into both of those. So this would be negative 5 over 3 when you reduce it. And then from here, I'm going to look at the variables. So just note here I have x's on the top and bottom. So I'm going to do 5 minus 2, bigger minus smaller. 5 minus 2 is 3. So the answer to this is x cubed. And that answer is going to go on the bottom because there's more x's on the bottom than there is on the top. Then I'm going to do the same thing with the y's. y cubed minus y over y cubed. 3 minus 3 is 0. So since when I subtract the exponents and the result is 0, basically what we say there is that these y's are going to cancel each other out, and I don't put anything in the fraction for the values of the y's. So the answer to this would just be negative 5 over 3x cubed. So just note here, just on the side, when you do y cubed over y cubed, what you're basically doing is this here. And this is why I don't put anything for the y's in my answer. This all cancels out. So if the y's all cancel out, then there's no y's to put in your answer. So just sort of note there that when you subtract the exponents, if the answer is 0, that means those variables cancel each other out, and that is not going to be a part of your answer. So that's just some different things that we do involving division with exponents. The other thing we're going to look at here involving division has to do with negative exponents. So just note here, when an exponent is negative, it means that the variable is on the wrong side of the fraction. So just note that the wrong side of the fraction, a variable and an exponent can only be on either the top or the bottom. So if you have a variable that has a negative power on the top of the fraction, what that means is it belongs on the bottom. And then if you have a variable to a negative power on the bottom of the fraction, what that means is that it's supposed to be on the top. So to make an exponent positive, what we do is we place the variable and the exponent on the other side of the fraction. And then when you do that, you turn the exponent into a positive. So some examples involving that would be this. So you have x to the negative 3 over y to the negative 2. So just note here, whenever you have a variable to a negative power, what I'm going to do is I want to make it positive. So what I'm going to do with x to the negative 3 is I'm going to put it on the whole thing on the bottom of the fraction, and when I do that, the power becomes positive. Same thing here with y to the negative 2. I'm going to take this, because it's a negative power, I'm going to put it on the other side of the fraction, and when I do that, the exponent becomes positive. And just note, because the variables are different, I can't do any canceling there. So the answer to this would just be y squared over x cubed. So that's just sort of a basic example involved with negatives there. So something like this, just note that the variables are the same, but what I want to do first is I want to make the exponents positive. So x to the negative 2, I'm going to put that on the other side of the fraction. I'm going to make it the exponent positive. Same thing, x to the negative 4, that's a negative power. I'm going to put that on the other side of the fraction, and I'm going to make that positive as well. So just note here that what we have is two variables that are the same. So when we're talking about division, remember the shortcut is to subtract the exponents, bigger minus smaller. 4 minus 2 is 2. So the answer to this is x squared. And the answer goes on the top because there's more x's on the top than there is on the bottom. And then I would have a 1 on the bottom since there would be nothing left on the bottom when I cancel. And then x squared divided by 1 would just be x squared. So that's the answer for something like that. So anytime you have variables that are the same on the top and bottom, just make sure that you're simplifying that with subtraction. So with this one here, just note I have coefficients, 5 over 15. So just like we talked about with division, always reduce the coefficients first. 5 over 15 reduces to 1/3. And then I have this, x to the negative 4. Well, it's a negative power, so I'm going to put it on the other side of the fraction. And when I do that, the 4 becomes positive. And then I have x to the negative 2, same thing here. I'm going to put that on the other side of the fraction. And when I do that, it becomes positive. And then just note here, we have variables that are the same on the top and bottom. So I can do bigger minus smaller. So just note that 1/3 stays 1/3. But when I do x squared over x to the 4th, 4 minus 2 is 2. So the answer to this is x squared. And the answer goes on the bottom because there's more x's on the bottom than there is on the top. So that would be the answer for something like that there. And then finally, just some different things with multiple variables and reducing and negatives and things like that. So once again, just note here, I'm going to reduce negative 4 over 10 first. And this reduces to negative 2 over 5 since 2 can go into both of those. And then I have the variables. So just note here, x to the negative 3. I'm going to put that on the bottom because it's a negative power, and I'm going to make that a positive 3. X to the negative 4, same thing. I'm going to put that on the top since it's a negative power, put it on the other side. That becomes x to the 4th. Y to the negative 2, once again, negative power, I'm going to put on the other side of the fraction. I'm going to make the exponent positive. Y to the negative 1, same thing. I'm going to put it on the other side of the fraction, and I'm going to make that positive. So that's what you get when you take all the exponents and make them positive. Now just note I can do some simplifying here. So negative 2/5 is going to stay negative 2/5. But when I have this here, x to the fourth over x cubed, the answer to this is x to the first. 4 minus 3 is 1, and the answer goes on top because there's more x's on the top than there is on the bottom. And then for the y, same thing here. 2 minus 1 is 1, so the answer to this would be y, or y to the first. However, the answer for this goes on the bottom because there's more y's on the bottom than there is on the top. So that's just some different things that are involved with some laws of exponents involved with division, as well as some different things involved with negatives.